Hi, we are on Chapter 6, Lesson 1, Part B, and we started our lesson yesterday was when the bases were the same, I would make the exponents into an equation, and I would just solve the equation. So I really wanted the bases to be the same, like both of them to be a 2, or both of them to be an x, or whatever it was. So today I'm continuing on with that, but our bases might not match today. And so we're going to talk about what to do in that case. So the power of a power product means that I'm going to, look at what my bases are and what my exponents are. And I'm going to make the bases match. And when they match, I can set the exponents equal. Okay, so let's start with this. Number 1. Let's write this using an exponent. This was on the homework for 6.1a. Write 4 with an exponent. So 4 can also be what to the power of what? 2 to the power of 1. 2 to the power of 2. Good. Okay. Then what could 9 become instead of a 9? What could I write? 3 to the power of 2. Awesome. 27 could be what? And you remember my little cheat sheet of all the important ones are on the board there. 27 becomes what? 3 to the third. 3 to the power of 3. Good. Okay. So now what's going to happen is I need to make the bases match. All right. Right now I have a 4 and a 2. They don't match. Let me zoom in. I have lots of space. So I really want them to be both something small. 4 can become what? What can I make the 4 instead of the 4? 2 to the power of 2. So 2 squared. So I'm going to write 2 squared. Now what do you suppose I do with the x? Can't. Yeah, put it next to 2. It can't disappear. It still is part of it, and it's still in the exponent. So the x has to go with that 2, the little exponent 2. So now it becomes 2 to the power of 2x. So 4 to the x is the same as 2 squared x. These things equal each other. And that's the whole point. We're trying to keep it easy for you. The right side already has a 2 as my base. So I'm good with that. 3x minus 6. Okay. I have the same bases. What do I do when I have the same bases? Yep, cross them. And I set the exponents equal. And I set them equal to make an equation, really. On the left side, I just have 2x. On the right side, I have 3x minus 6. All right. This is just solving for x. End goal, I want x equals. I need to combine like terms. I need to get things together. What's together? What's the same? What would I move first? And it also is very painful when I'm recording and no one volunteers. Lots of silence. The x's. Which one should I move? To the right, to the left? What? 3x? Is that what you were going to say? Great. It's a positive 3x. Subtract 3x both sides. Both sides, BS. So 2x take away 3. 2 minus 3. Negative 1x equals negative 6. And then get the x alone. Divide by negative 1. X equals 6. Awesome. All right, C. I really want the bases bases to both be the same. I've got a 4 and I've got a 2. That's not going to work. What should I make both bases? Make them both into 2's, yeah? Because the 4 is 2 squared. The left side looks perfect as it is. I'm happy. Don't change a thing. But the 4, however, will become 2 squared. What do I do with the negative 12? Multiply it. I put it in parentheses because I don't want you to do 2 minus 12. I want you to do 2 times negative 12. This is good. My bases are the same. They're both 2's. I'm going to cross out my same bases and get 3m equals negative 24. 2 times negative 12 is negative 24. Okay, finish it off. Solve for m. M equals negative 8. All right. No more 2's and 4's. I have 27 and a 3. So what do I make the 27?
3.
3 to the power of 3. 3 cubed. I'm going to have to multiply. X minus 4. And the 2x minus 6 stays as is. It looks good. The 3's are both the same base. Good. Set the exponents equal, make it into an equation. Three times the quantity x minus 4 equals 2x minus 6. So I have to distribute that 3. The 3 needs to be multiplied by the x, and the 3 needs to be multiplied by the negative 4. 3x minus 12 equals 2x minus 6. Get the x's together. Get the 12 and the 6 together. I've a couple rules that I've taught my Algebra 1 kids before. Move the smaller variable is smart, like move that 2x. Or you could get all the variables on the left side. That's another tip that really helps. So with that in mind, that means that I'm going to move this positive 2x. I move it by subtracting 2x. X take away 12 equals negative 6. Get the 12 over. It's a minus 12. How do I move a minus 12? Add 12. Because I want it to disappear. Negative 12 and positive 12 makes 0. This is good. X equals negative 6 plus 12. 6, positive 6. Okay. On the back side, this is your example. So let's do a little recap of fractions. Like 2 to the negative second becomes 1 over 2 squared, right? Becomes 1 over 4. Now, the reason I did this example is because I started with the negative exponent, I ended with a fraction. What if I start with a fraction? How about 1 over 8? How do I make an 8? It's on the board, my list. 2 cubed. So that would be like 1 over 2 cubed. But I really don't want it in the denominator. I really want it as a negative exponent. How do I make this 1 divided by 2 cubed into a negative exponent? New volunteers. What makes things drop into the denominator? What's that exponent rule? I'm hearing people say negative exponents. You're right. So instead of 1 over 2 to the third, I'm going to have a whole number 2. And what am I going to put as the exponent? Negative 3. I just went backwards and forwards. I just did negative exponent becomes a fraction. What if I have a fraction? It can change it to a negative exponent. So these 25s, 1 over 25 was what? 1 over, what makes 25? Change it into an exponent. 5 squared, right? But, yeah, 5 to the whole number 5 to the negative second. I need that for this parentheses that says 1 over 25. This is going to be 5 to the negative second times 4f. Okay, tell me about 1 divided by 125. I'll do it over on the side just to keep us all like 5 to the power. It's on the board still. 5 to the power of 3. Good. Okay. So, whole number 5 to the what? Negative third. Which means this parentheses is going to be 5 to the negative third to the 16th. Okay. Whew, the bases are the same. This is good. I'm now going to make sure that my exponents are all combined. This is a multiplication. Negative 2 times 4f. Negative 8f. No more 5s, right? And what's negative 3 times 16? 16, 32. I'm 48. Okay. Solve for f. Divide by negative 8. F equals 6. Okay, we're going to stop there just for time. We're not going to do, so I'll stop the recording.